All right, hello Trig fans. All right, this is day 3 of chapter 1, and first thing we're talking about are vertical angles. You guys remember this from geometry? Okay, remember vertical angles are congruent. Okay, so if I have A, B, C, D, E, and I say this is 2x plus 10, and this is 4x minus 20, I'll ask you guys to find the measure of angle AED. Okay, you're going to basically, now this is where you set equal, right? Where you had complementary, you set equal to 90, supplementary, you set equal to 180. This one you set it equal to each other, so 2x plus 10 equals 4x minus 20. And we move things over, so we get 2x is equal to 30, x equals 15. Okay, again, that's going to be, it's a great ACT question where they just put x equals 15 on there, but if I'm asking for AED, you just plug it in. So it's 2 times 15 plus 10. So 30 plus 10 is 40. So the answer is 40 degrees. All right, now another good question would have been find AEB. Okay, and of course AEB would have been, you know that this is 180 degrees right here. So you do 180 minus 40, which is 140 degrees. Okay? All right, so let's try another one here. Just to remind you guys, right, 180 degrees in a triangle. And if I give you a nice triangle like this, and I said this is x plus 4, and this is 2x minus 7, and this is 3x minus 9, and I say that's A, B, and C, and I say find measure of angle A. Okay, so you're just going to set them all equal to 180. So x plus 4 plus 2x minus 7 plus 3x minus 9 equals 180 degrees. Okay, combine like terms. You get 6x minus 12 equals 180. So 6x equals 192. And divide by 6, x equals 32. Again, don't put 32 down there. I'm looking for the measure of angle A. So measure of angle A is 32 plus 4, which is 36 degrees. And and again, don't forget to put your degree symbol in there. That's really as a unit. All right. Okay, we talked about this yesterday. How many degrees is that? We don't know. Now it's 90. Okay, and these angles are supplementary because it's a straight angle. And so that's why this guy right here is going to be 180 degrees. And let's talk about parallel lines. If I give you guys 2 lines and I draw a transversal in there, what can you tell me about this angle right here and this angle? Okay, you actually can't tell me anything now. Okay, you can definitely tell me they're alternate interior. But I need to put these little symbols on here because they have to be parallel in order to say these are now congruent. Okay? Same thing with this. If I, again, say that these are parallel, a couple things, right, like this one and this one are going to be supplementary. Okay, let's talk about similar triangles. Okay, so similar triangles, basically the sides have to be proportional to the sides of the other triangle. So sides proportional. Right, so I can also show, of course, the sides can be proportional, but if the angles are congruent, so if angles are congruent, then it's also similar triangles. Okay, and if you guys remember, that's basically saying angle-angle similarity. All right, so obviously once you prove 2 angles are the same, the third one's automatically the same because you're going to subtract it from 180. Okay, so if I give you triangle A, B, C and triangle D, E, F, in order to make triangle ABC similar to triangle DEF, okay, what you need to do is really make these congruent, A and D, because remember that has to match up, and then B and E have to match up. There's B and E, and then C and F have to match up. So C and F match up. Okay, and then you can say those triangles are similar. Now I can give you one looks like this, and you guys probably even remember this from back in the day. Okay, are these triangles similar? No, they're not. But if I make these parallel, now they're similar. Okay, because basically what it is, if you think about it, let me do this in red here. Those are parallel lines, and here is your transversal, and we can even extend those lines, right, like that, and like that, just to kind of help you a little bit. And right here, guys, those are alternate interior angles. All right, so those are congruent. Of course, these are congruent because of vertical angles. And, you know, if I want, I can say these are also congruent because of alternate interior, or because it's angle-angle similarity, so the third angle has to be the same anyway. All right, so those two triangles are similar triangles, and of course you have to kind of match things up a little bit too, right? If I do A, B, C, D, E, you have to say triangle A, B, C is similar, and then match it up. That's pretty easy. Triangle E, what goes with B? Well, D. And what goes with C? Well, C goes with C. So there you go. Triangle ABC is similar to triangle EDC. All right. Can also have a triangle here, and this is 12, 9, and 15. And here's another triangle, and this is going to be, and here let's mark this also, that, and this is 6, Y, and X. Now I'm telling you these triangles are similar, and you know they're similar because of angle-angle similarity. All right, and then what I'm trying to do is I'm trying to find out the value of X and Y. Well, if they're similar, you can set up your proportions. So I can say this one, 9 over 6 is equal to, and you can do it any way you want, so let's do X, 15 over X. Cross multiply, 9X equals 90, so X equals 10. All right, and then I can figure out what the value of Y is you can do the same thing. 9 over 6 is equal to 12 over Y. Now, if you wanted, you could actually simplify this a little bit ahead of time. I can simplify this fraction, right? Isn't that 3 halves? And then I get 3y equals 24. Divide by 3, y equals 8. Okay, those are your two answers. Okay, not too bad, right? Okay, so let's do a quick application here. So this is an application. A goalpost. It's a good application. You might have studied this a lot in geometry. But a goalpost casts a shadow 75 feet. Okay, Mr. X, very scary. Mr. X is 6 feet tall. And his shadow is 20 feet. How tall is the goalpost? I'll tell you, this is a great application, and not necessarily maybe the goalpost, because you can say, well, gee, I know how tall the goalpost is, but let's say it's a tree. Okay, I need to buy a ladder, I need to buy a trimmer to go to the top of the tree, and I don't know how high the tree is. Or maybe even, you buy a house, and you're like, geez, I wonder how high that house is, and you know, you want to buy a pole to maybe to paint the side of the house or something. a good way to do it is, you know how tall you are. You measure your shadow. You can measure the shadow of the house, and then you can easily figure out how tall the house is. All right, it's a great application. Okay, so anyway, here is this is the goal post, and here's the shadow, and that shadow is 75 feet. All right, and here is Mr. X. So Mr. X, and he is 6 feet tall, and his shadow is 20 feet. And you're trying to find X. So it's really easy. Again, you're going to set up a nice little proportion here, and it doesn't matter, kind of doesn't matter how you set up, as long as usually you say X over 6, right? Because that matches up. That's the height over that height is equal to, and these are similar triangles. Okay, because it's the sun is kind of shining the same way, so the angle is going to be the same. I guess if you want to just draw even the triangle here, right? This is a right angle here, and this angle is going to be the same. So these definitely are similar triangles. So x over 6 equals 75 over 20. All right, you cross multiply, and you get 20x is equal to 450. And we divide by 20, and x comes out to be 22.5. And don't forget your units. That's actually really important. I'm going to be looking for that on quizzes and tests. If you forget your units, you're going to lose 1 point off of that. All right, so don't forget that. All right, another application problem here. It's not really an application. This is a really good problem, though. Okay, and I have another problem like another line like this. So these are right angles, and I say this is 8 inches, this is x, and this is 5 inches, this piece right here, and this piece right here is 20 inches. And you're trying to find the value of x. Now the tricky thing about this is people love to say, okay, the 8 goes with the 5 and the x goes with the 20, but that's not true. Truly what these guys are separate triangles, math fans, okay? So I'm just going to, you don't have to draw this, but I just want to show you, this is your 8, and this whole length is 25. And then you got the smaller triangle, and that's x, and that is 20. That's really what you're looking at, okay? If that helps you distinguish between the two triangles, then you do that. And these triangles are similar triangles because they share this corner here. Okay? So again, these are right angles here, and then obviously they're similar triangles. So you can say 8 over x equals 25 over 20. Okay, cross multiply, and you get 25x equals 160 divided by 25. X comes out to be 6.4, and again, don't forget inches, your units. All right? Okay, so now we're going to talk about the definition of trig functions. So let me actually get rid of this little writing here because I'm going to need to write a lot. This is the definition of trig functions. Okay, first of all, we can draw our xy coordinate plane here, and we're going to draw an angle. Okay, and this point right here has an xy coordinate, so that means that's an x, and that's a y value, y distance. And we're going to call this r. This is like the radius. Okay, so that's the radius here. And this angle here is theta. Okay, so a couple things here. First of all, let's just use a little Pythagorean theorem. This is, of course, a right triangle here. X squared plus y squared equals r squared. Okay, r is always going to be greater than 0. Has to be greater than 0, otherwise it's going to be a point on the origin. It makes sense, right? It's got to be greater than 0. And r is not going to be a negative value. So x and y can be positive, negative, or can be 0. All right, so that's pretty important. Okay, so let's actually these are our trig functions here now. This is actually huge. Trig function. This is so important, and I'm gonna. This is, I just can't stress this enough. You need to memorize this. That is so huge. Okay, I'm gonna highlight this. You got to memorize that. All right. The first one is sine of theta is equal to y over r. The cosine of theta is equal to x over r, and the tangent of theta is equal to y over x. Okay? The next functions here are our reciprocal functions. And basically you have, it's called cosecant of theta is equal to the reciprocal, so it's equal to 1 over sine of theta. So it's just going to be r over y. Okay, and then you have the secant of theta is equal to 1 over the cosine of theta. So that's going to be r over x. And then you have the cotangent of theta is equal to 1 over the tangent of theta, or x over y. All right, got to memorize those. You have to know those. They're really not that difficult. A couple things, the way to memorize this, which I'm not going to spend too much time on that, but this is y over x. Y over x. Ah, very interesting. There comes the yox. I wonder what the yox is. Well, if you are watching this video and you don't see the, if you have not in class and you're watching this video, you definitely need to ask me in class what the yox is. Okay, I'm not going to explain it here now and make the video longer, but the yox is actually very, very important, and we'll talk about that, so ask me. Okay, so that's the yox, and this is x over y. So it's the xoi. That's another important thing, too. Okay, so I'm going to kind of show you guys some easy ways to remember these, but the yox is for tangent, and the cotangent is the xoi. Okay? So this is, again, this is really important to memorize. I unfortunately have to delete this to make room. You know what? I'm going to move it down a little bit. All right, so here's your example. It says, given the terminal point 4, -3, find the value, or find the values of all 6 trig functions. All right, so I think a really good thing to do is if you make a quick sketch here. Okay, you get 4, -3. So we're 1, 2, 3, 4, -3. So I'm going to put a point here. And there's your ray. So what you have here is you have your value of course, x is equal to 4, y equals -3, and r equals, you just use Pythagorean theorem. So 4 squared plus -3 squared and the square root of that, right? So r is equal to, well, this is just, you know, this is a 3, 4, 5 triangle, so r is equal to 5. And then you just plug it back in all those friendly little functions we just learned. Okay, so I'm going to ask you the sine of theta, okay, this being theta, and the sine of theta is equal to y over r, so it's -3/5. That's really easy. Cosine of theta equals x over r, so it's 4/5 positive, and the tangent of theta is equal to y over x, or -3/4. And then the other ones are really easy. Cosecant of theta is equal to -5/3. Secant of theta is equal to 5/4. And the cotangent of theta is equal to -4/3. And that's it. Now, sometimes people have a hard time remembering. This is an issue, that sine goes with cosecant. People think sine goes with secant, and cosine goes with cosecant. Okay, the way you got to remember all this stuff, guys, is whenever you're on an airplane, a pilot always needs a co-pilot. Okay, so like right here, sine goes with cosecant, a sine and a co. A cosine goes with a secant. So there's a pilot and a co-pilot, and of course tangent goes with cotangent. That's easy. So a pilot always needs a co-pilot. So you've got to remember it that way, and I think that's going to help you out. All right? Okay, let's try one more here. And I'm going to erase this. Okay, so we're going to do, the point is negative 2 root 2, comma, 1. So that's really not that bad. Again, it's really easy. X equals negative 2 root 2, and y equals 1. That's really easy. Okay, so then what you're going to do is the only thing you need to find here is you need to find the value of r. So we have r equals 2 root 2, really it's negative 2 root 2 squared plus 1 squared, and the square root of that. So r is 2 root 2 squared is 8 plus 1 square root of that, so it's square root of 9, which is 3. R is 3. So now it's just literally, you plug everything in. So I have sine of theta is equal to y over r, so 1 over 3. Cosine of theta equals x over r, so negative 2 root 2 over 3. And tangent of theta is equal to y over x, so it's negative 1 over 2 root 2. You rationalize it, definitely, so it's negative root 2 over 4. Multiply the top and bottom by root 2 over root 2. Okay, that's pretty easy. And then the rest of them are easy, right? Cosecant of theta is equal to the reciprocal, so that's equal to 3. Secant of theta, do the reciprocal of that, and you rationalize it, and you get negative 3 root 2 over 4, and you have the cotangent of theta. And actually, as opposed to trying to rationalize this one, this is actually equal to that, as opposed to trying to rationalize this one, well, isn't it this guy right here? Isn't it x over y? So it's just negative 2 root 2 over 1, or just negative 2 root 2. Sometimes it's easier just to look at the original problem. Okay? And that's it. That's it, my fans. Watch your signs, and just memorize those 6 trig functions. Really, you have to memorize just 3 of them, and then you know the reciprocal is the other 3 functions. All right? That's it, my fans. Have a great day. Goodbye.